Hello, good morning, dear students. We have been studying about the catalyst into the surface chemistry. Now we'll study about the last topic for this particular part of the surface chemistry, that is catalyst in the industry. Some of the important technical uh, some of the important technical catalytic process are listed below that give idea about the utility of catalyst in the industry. The first process that we are going to study here is the Haber's process. This Haber process is for the manufacture of the ammonia. You can see N2 plus, it should be 3H2. N2 plus 3H2, it gives twice NH3. Catalyst used. So what catalyst do we use? We use finely divided iron as a catalyst, molybdenum as a catalyst, molybdenum as a promoter. And what are the favorable condition or optimum condition? That is 200 bar pressure and 723 to 773 Kelvin temperature. Or at present nowadays, what kind of catalyst we use? Iron oxide as a catalyst, potassium oxide, that is K2O, and aluminum oxide, that is Al2O3, as a promoter. What are the conditions that are needed for a better reaction to take place? So the condition that we set is 200 atmospheric pressure, or 200 into 10 to the power 5 Pascal, and 700 Kelvin temperature. Then we have the next process. The name of the next process is a Ostwald process for the manufacture of nitric acid. It takes place in three steps. In the first step, we oxidize ammonia, so 4NH3 plus 5H2O. In the presence of catalyst, it gives us 4NO plus 6H2O gas. Then we take 2NO and oxidize it to 2NO2, and then we have 4NO2 plus 2H2O liquid plus O2 gas, that gives us the nitric acid 4HNO3. You can see here the catalyst is needed in the first step. So catalyst is in the first step needed only. We use the catalyst as a platinized asbestos, and we maintain the temperature as 573 Kelvin. Then we have the next process, which is known as the contact process. Contact process is used for the manufacture of the sulfuric acid. So you can see that 2SO2 plus O2, in the presence of catalyst we get 2SO3. Then 2SO3 is dissolved into the H2SO4. This is a gas which is dissolved into the solution of H2SO4. We get H2S2O7, which is also known as the oleum or fuming sulfuric acid. And then by adding water into this fuming sulfuric acid, we get the sulfuric acid. Here catalyst is needed only in the first step, and the catalyst that we can use here is either vanadium pentoxide, or we can use platinized asbestos. So the same I have written here. The catalyst used is platinized asbestos, or we can use vanadium pentoxide. Your formula for vanadium pentoxide is V2O5. So this is what we can use here. Now there are some in-text question that we need to discuss, and some exercise question. So let us discuss those in-text question and exercise question. In Haber process, hydrogen is obtained by reacting methane with steam in the presence of NiO, nickel oxide, as a catalyst. The process is known as steam reforming. Why is it necessary to remove carbon monoxide when ammonia is obtained by Haber's process? So the main question is, why do we need to remove carbon monoxide? The answer, let us see. Carbon monoxide will act as a poison for catalyst in the Haber process. Thus carbon monoxide will lower the activity of the catalyst. Thus carbon monoxide must be removed when ammonia is produced by the Haber process. It's very simple to understand that for Haber process, carbon monoxide behave as a poison which decreases the rate of reaction, and as the rate of reaction is decreased, we need to remove it from the reaction mixture so that we can have a better catalytic properties. Now we'll go for the next question. Why is ester hydrolysis slow in the beginning and faster after hydrolysis? So the answer is, ester hydrolysis is catalyzed by H plus ions. H plus ions are produced by acids. Ester hydrolysis give alcohol and acids. Acid means carboxylic acid. The acid produced as a product will also produce H plus ion. This H plus ion will again catalyze the reaction. The product behaves as a catalyst, which is also called the autocatalysis. Due to production of H plus ion, the rate of reaction increases, so hydrolysis turns faster. So the product formed also behaves as a catalyst, and that is why the rate of reaction has been increased and we get it. What is the role of desorption in the process of catalysis? We just need to understand the role of desorption into the catalysis. So in the process of catalysis, when desorption takes place, what happens, we'll see that what happens when the desorption takes place. When the desorption takes place, the surface of catalyst become free for further adsorption and for further catalysis. So when the desorption takes place, the product are removed from the surface of catalyst, and ultimately the catalyst is again ready for the another adsorption, and that is why the same catalyst can be used again and again for the reaction. And this is how the desorption is very important for the process of catalysis. The next question: what are the factors which influence the adsorption of a gas on a solid? So let us study the factors that affects the adsorption of gas on a solid. The extent of adsorption of a gas on a surface of solid is affected by the following factors. What are these factors? Number one, nature of gas, what type of gas it is. Second is nature of adsorbent, what kind of adsorbent it is. Surface area, the more is the surface area, the more is the adsorption. Effect of temperature, the physisorption is decreased by temperature, whereas sometimes chemical or mostly the chemical adsorption is increased by temperature. Effect of pressure, the more is pressure, the more is gas, and that is why the pressure in as the pressure increases, the adsorption increases, and at some pressure it reaches the saturation level. And activation of adsorption, if we activate the adsorbent, it can have a better quality, and that is why it absorbs the gases very well. Now we have the next question: what role does adsorption play in the homogeneous catalysis? So now we'll understand the role of adsorption into the homogeneous catalysis, into the heterogeneous catalysis. I'm sorry, it is heterogeneous. Heterogeneous means the physical state of adsorption and catalyst are, sorry, physical state of reactants and catalyst are not same. In the heterogeneous catalysis, the reactants are generally gases while catalysts are solids. So both have the different phase. The reactant molecules are adsorbed on the surface of catalyst by physisorption or chemisorption. Any type of adsorption is possible. Thus, the concentration of reactant molecule increases on the surface of catalyst due to the adsorption, and thus the rate of reaction is increased, which is called the effect of catalyst. So we can easily understand that adsorption increases the concentration of the reactants on the surface of catalyst, and that is how the rate of reaction has been increased. In the next video we will see about the colloids, my dear students. Thank you. Happy learning.